330 light years away, scientists just found a giant planet that shouldn't exist according to almost everything astronomers thought they understood about planets this size. It's roughly the size of Saturn, but instead of being locked in freezing cold like every giant planet in our own solar system, or blasted with scorching heat like most giant planets found around other stars, this world sits in a genuine sweet spot, mild, temperate, and shockingly close to Earth-like temperatures. NASA has confirmed the findings, and researchers are calling it one of the most important exoplanet discoveries in years. Let's start with why this planet, officially named TOI 199b, has scientists so genuinely excited, because the backstory here matters. For the past 2 decades, almost everything astronomers have learned about giant planet atmospheres beyond our solar system has come from studying what scientists call hot Jupiters. These are massive gas giants that orbit incredibly close to their host stars, often reaching temperatures in the thousands of degrees, hot enough that even metals like iron can evaporate directly into the atmosphere. Hot Jupiters are relatively easy to study because they orbit so close to their stars that they transit frequently, passing in front of them again and again, giving astronomers plenty of opportunities to gather data. It's worth understanding just how dominant this particular type of research has become within the field. When astronomers first started successfully analyzing exoplanet atmospheres in meaningful detail, hot Jupiters were essentially the only realistic targets available with the technology at hand. They're large, they orbit quickly, and their close proximity to their host stars produces strong, easily detectable signals. Over time, this practical advantage snowballed into an entire subfield of astronomy, almost exclusively built around these scorching extreme worlds, simply because they were the planets scientists actually had the tools to study properly. That imbalance created a genuinely awkward gap in scientific knowledge. Astronomers had built an impressively detailed understanding of atmospheric chemistry at one specific temperature extreme, while remaining almost completely blind to how those same chemical processes might behave anywhere else along the spectrum. It would be a bit like trying to understand ocean ecosystems by only ever studying life at the very bottom of the deepest trenches, while never once examining the shallow coastal waters just a short distance away. But that convenience created a massive blind spot in planetary science. Almost every detailed atmospheric study ever conducted focused on these extreme, blisteringly hot worlds, while a completely different category of giant planet, one sitting in a much milder temperature range, remained almost entirely unstudied. Scientists knew these temperate giant planets existed. They just didn't have the tools or the opportunities to actually examine what their atmospheres were made of in any meaningful detail, until now. TOI 199b changes that completely. This Saturn-sized world orbits a sun-like star located in the constellation Dorado, completing a full trip around its star roughly every 100 days. That orbital distance places it in a genuinely rare thermal zone, receiving about 2.5 times the amount of radiation Earth gets from our own sun, which works out to a surface temperature of approximately 175 degrees Fahrenheit. That's still far too hot for anything resembling life as we understand it, but compared to the 1,000-degree hot Jupiters that dominate most exoplanet research, it's remarkably mild, almost gentle by comparison. In terms of raw physical size, TOI 199b carries roughly 17% of Jupiter's mass, while measuring about 81% of Jupiter's radius, giving it an internal structure researchers describe as closely resembling Saturn, complete with a hydrogen-dominated atmosphere wrapped around its core. The star it orbits also hosts at least one additional massive planet, designated TOI 199c, adding an extra layer of complexity that researchers are still working to fully understand as they continue studying this entire planetary system in greater detail. Researchers led by teams at Penn State University and NASA's Jet Propulsion Laboratory pointed the James Webb Space Telescope directly at this planet to figure out exactly what its atmosphere was made of. They used a technique called transmission spectroscopy, an elegant method that doesn't require photographing the planet directly at all. Instead, astronomers wait patiently for the planet to pass directly in front of its host star from Webb's point of view. As that happens, a thin sliver of starlight filters directly through the outer edges of the planet's atmosphere before continuing on toward the telescope. Here's where the real magic of this method comes in. As that starlight passes through the planet's atmosphere, specific gases inside that atmosphere absorb very particular wavelengths of light, essentially leaving behind a unique chemical fingerprint embedded directly within the starlight itself. When Webb splits that light apart into its individual wavelengths, scientists can examine exactly which specific colors are missing or diminished and match those gaps against known chemical signatures to identify precisely which molecules exist within that distant atmosphere. This technique requires an almost extraordinary level of precision. TOI 199b sits more than 330 light-years from Earth, meaning the star it orbits appears only as a single point of light even through Webb's powerful instruments. Astronomers aren't looking at some detailed, zoomed-in photograph of the planet itself. They're measuring incredibly subtle dips and variations in starlight brightness across different wavelengths, changes so small they can only be detected using instruments as sensitive as those on board the James Webb Space Telescope. It's a bit like trying to identify the specific ingredients in a drink, simply by analyzing how a beam of light changes color as it passes through the glass, except the glass in question is an entire planetary atmosphere hundreds of light years away. And what they found was genuinely significant. Webb detected clear, unmistakable evidence of methane within TOI 199b's atmosphere, along with fainter, less certain hints of ammonia and carbon dioxide that will require additional observations to fully confirm. This marks the very first time scientists have successfully detected methane, specifically within the atmosphere of a temperate giant planet, providing researchers with their first real data point in a category of world that had remained almost completely unstudied until this moment. If you're new here, this channel breaks down the most exciting confirmed discoveries coming out of deep space right now, so go ahead and hit that subscribe button so you don't miss what's coming next. Why does finding methane matter so much to scientists? Because for years, theoretical models had actually predicted that temperate giant planets like this one should contain methane in their atmospheres, based purely on the underlying chemistry expected at these specific, moderate temperature ranges. Methane is actually a fairly fragile molecule in astronomical terms. In the scorching heat of a typical hot Jupiter, methane simply can't survive, breaking apart under those extreme temperatures almost as quickly as it forms. But in a cooler, more temperate environment, like the one found on TOI 199b, that same molecule can persist and accumulate, exactly as those theoretical models had predicted all along. Interestingly, methane isn't a stranger to Webb's discoveries elsewhere either. The telescope had previously identified methane in the atmosphere of a much smaller, cooler world called K2-18b, a discovery that drew enormous public attention at the time. But TOI 199b represents something genuinely different. The first time this specific molecule has been confirmed within a giant Saturn-sized planet sitting in this particular temperate zone, giving researchers a completely new comparison point for understanding how planet size, temperature, and atmospheric chemistry all interact together. What makes this discovery so exciting isn't just that scientists found an interesting chemical signature. It's that this specific finding validates decades of theoretical chemistry that had never actually been tested against a real, observed planet in this precise temperature category before. Researchers involved in the study explained that this success gives them genuine confidence that their broader understanding of atmospheric chemistry holds up correctly when finally checked against real physical data, rather than relying purely on computer models and educated extrapolation. Think about what that actually means for the field of planetary science as a whole. For 20 years, scientists have been building increasingly sophisticated models predicting how different types of planetary atmospheres should behave, based largely on data gathered from extreme, easily observable worlds. TOI 199b represents the first genuine opportunity to test those models against a completely different category of planet, one existing in that previously unexplored middle ground between blistering hot Jupiters and the frigid gas giants found in our own solar system. And remarkably, the actual data lined up closely with what those models had predicted. That kind of confirmation matters enormously in science, even when it doesn't produce a dramatic, unexpected twist. There's sometimes a tendency to assume the most exciting scientific results are always the ones that upend everything we thought we knew. But confirming that decades of careful theoretical work actually holds up when finally tested against real data is its own kind of breakthrough, one that gives researchers genuine confidence to build even more ambitious models going forward, knowing their foundational assumptions have now been validated against an actual observed world. There's also a broader scientific mission at play here that goes beyond just this one specific planet. Scientists have explained that studying worlds like TOI 199b ultimately helps researchers build a more complete, accurate picture of how planets and their form and evolve over time throughout the entire galaxy. Every new data point from a previously unstudied category of planet helps fill in gaps in our overall understanding, refining models that could eventually be applied to countless other worlds, including, in theory, planets that might actually be capable of supporting life someday. To be completely clear, TOI 199b itself is definitely not a habitable world. It's a massive gas giant with no solid surface, roughly the size of Saturn, and while its temperature is dramatically milder than most giant planets studied so far, it's still far too warm and far too different in composition from Earth to ever support life as we understand it. But researchers emphasize that understanding how atmospheres behave across this entire range of temperatures, from blazing hot Jupiters all the way through these newly studied temperate giants, ultimately strengthens the broader scientific toolkit. Scientists will eventually use when searching for genuinely habitable worlds elsewhere in the galaxy. The research team has already indicated they're planning to gather additional observations of TOI 199b in the future, specifically aiming to pin down the exact relative abundances of methane, ammonia, and carbon dioxide within its atmosphere with much greater precision. They're also hoping to determine whether the planet's atmosphere includes clouds or hazes, something the initial data couldn't fully confirm one way or the other. Beyond that, scientists are already looking towards studying other temperate giant planets using the same successful approach, hoping to determine whether TOI 199b's specific atmospheric chemistry represents a common pattern shared across this entire category of world, or whether it's a genuinely unique case all on its own. That question alone could keep astronomers busy for years. If temperate giant planets consistently show similar atmospheric patterns to what's been found on TOI 199b, it would suggest a predictable universal chemistry governing this entire class of world throughout the galaxy. But if future discoveries reveal wildly different atmospheric compositions from planet to planet, even among worlds sitting at similar temperatures, that would suggest something far more complex and individually variable is What's genuinely remarkable about this entire achievement is what it represents for the James Webb Space Telescope itself. Launched in December 2021 and now stationed roughly 1 million miles from Earth, Webb was specifically designed with the kind of extraordinary infrared sensitivity required to detect these incredibly faint chemical signatures buried within starlight passing through a planet's atmosphere from hundreds of light years away. This level of detailed atmospheric analysis on a temperate giant planet simply wasn't achievable with any previous generation of space telescope, making TOI 199b's atmospheric profile a genuine first in the history of astronomy. Positioning the telescope so far from Earth wasn't just a logistical choice either. It was absolutely essential to making a discovery like this possible in the first place. Here on Earth, heat radiating from the planet itself, the atmosphere, and even nearby equipment would completely overwhelm the incredibly faint infrared signals Webb needs to detect. By operating nearly 1 million miles away, shielded behind a massive sunshield roughly the size of a tennis court, Webb's instruments stay cold enough to pick up on temperature and chemical signatures that would be utterly impossible to detect from the ground, no matter how powerful an Earth-based telescope might otherwise be. So think about the sheer scale of what just happened here. Light left a star 330 years ago, back when much of what we now consider modern science hadn't even been developed yet. That light eventually passed through the thin outer atmosphere of a massive temperate gas giant, picking up a chemical fingerprint along the way, before finally reaching a telescope stationed 1 million miles from Earth, where scientists were able to pull that fingerprint apart and identify the exact molecules hiding within it. That's the process that just gave researchers their first real glimpse into an entirely new category of planet. And this really is just the beginning. Researchers have made it clear that TOI 199b is essentially their opening data point in what they hope becomes an entirely new subfield of exoplanet atmospheric science, one dedicated specifically to these overlooked temperate giants that had been sitting in plain sight for years without anyone having the tools to properly study them. If you enjoy following along as these kinds of discoveries unfold, go ahead and subscribe, because upcoming observations of similar worlds could reveal whether TOI 199b is a fairly typical example of its kind, or something genuinely unique in the galaxy. If this discovery genuinely excited you, make sure to like this video and subscribe, because there are so many more incredible, confirmed discoveries coming from deep space, and you will not want to miss a single one of them.